The clearance and safety requirements of the job are also a concern during planning. Make sure that you're aware of obstructions such as tree limbs, buildings, and telephone lines that might complicate the rigging. Often, rigging a job on an overhead distribution system will require working around energized or potentially energized equipment. Whenever work is done around energized equipment, the equipment must be properly covered with line cover gear, and a safe electrical clearance must be maintained in order to minimize the risk of a shock hazard. Recommended safe electrical clearances vary according to the voltage and to specific company procedures. The clearances are usually published in a chart like this one. Here, the minimum safe electrical clearance from primary equipment energized at 13,200 volts is 2 feet. Care must be exercised when rigging a job so that safety is not compromised by reducing the recommended safe clearances. For example, here line cover gear is being used to insulate all energized primary equipment in the work area. The crew is careful not to allow the rigging equipment, such as rope, to make contact with any of the energized equipment. Once the job is planned, the crew can proceed with the next element of safe rigging practice, which is to carefully inspect the rigging equipment. It's important to check all of the equipment that will be used to make sure that it's in good condition and that it's the right equipment for the job. Equipment that's damaged or undersized can cause problems in completing the job. If the rigging equipment cannot do the job properly, everything may have to be moved back to its original position. Then the job will have to be rigged again with the right equipment. Worse yet, the equipment can fail, causing loss of load control, personal injury, damage to other equipment, and power outages. The final safe rigging guideline is using the equipment properly. Each piece of rigging equipment is designed to perform a specific task. Using a piece of equipment to do a job it is not designed to do, or exceeding the capacity of the equipment, can cause an accident. Later in the program, we'll see several examples of various types of rigging equipment being used on the job. For now, let's take a look at some of the more common types of rigging tools. They include rope, slings, block and tackle, hot hoists, and gin poles. Rope used for rigging is manufactured in a variety of materials and diameters to meet different requirements. The manufacturers rate each type and size of rope as to its safe working load. The ratings are often published in chart form like the one you see here. The value for the safe working load of any rope given in the chart is for new, clean rope. Used rope will have a lower safe working load. Like any other tool, rope should be well taken care of. That means not exposing it to heat or contaminants, or subjecting it to kinks or other physical stresses that would damage or weaken it. When rope is not being used, it should be coiled and stored. Slings are used to provide a method of connecting rigging tools to a structure or equipment. They can be made of a variety of materials, such as rope, webbing, or steel, depending on how they're to be used. Often, slings are made in a continuous loop, or with a loop at each end to make attaching them to equipment easier. Each size and type of sling is generally rated according to the load that it can safely handle. One thing to keep in mind about a sling is that the angle formed when it's attached to a load will determine the amount of strain it must support. In this simplified illustration, we can see that 2 slings are used to rig a 1,000-pound piece of equipment so that it can be lifted. The weight of the load pulls directly down on both slings so that each sling supports 500 pounds. If the slings are used at an angle to a straight lift, the load supported by each sling increases. At 30 degrees, each sling supports 577 pounds. And at 45 degrees, 707 pounds. At 60 degrees, each sling must support a full 1,000 pounds, even though the weight of the load itself has not increased. The next rigging tool that we'll look at is a block and tackle. A block and tackle is one type of device that's used to apply a mechanical advantage when controlling a load. While these devices come in a variety of sizes and configurations, they all usually have 3 elements in common. a fixed block, a movable block, and a rope. Now, both the fixed and movable blocks are made of a shell and several sheaves or rollers. The way that a block and tackle is rigged will depend on the specific job. In this case, the fixed block is attached to the permanent structure during rigging. The movable block is attached to the equipment being moved or held in place. A hook on each block is used to attach the block and tackle between the structures and the equipment being controlled. The rope is attached to one of the blocks at a bracket called the becket. The rope is then threaded or reeved between the two blocks in a pattern that takes the rope over each sheave. The end of the rope then runs to the ground. Now, the number of times that the rope runs from one block to another determines its mechanical advantage. In this example, there are 4 passes or falls of rope between the blocks. This gives the block and tackle a mechanical advantage of 4-to-1. A crew member would only have to exert a force of 100 pounds to lift a 400-pound load. Now, a hoist can also be used to apply a mechanical advantage to a load. The hot hoist is a ratchet-operated device designed to pull and hold. Its basic parts are the ratchet assembly, a handle, a direction selector lever, and a fiber strap. This type of hoist is called a hot hoist, as it's designed to be used on energized equipment. The material of the fiber strap is designed to provide insulation between the structure and the object being moved. As with a block and tackle, the specific requirements of the job will determine how a hoist is rigged. In this case, the ratchet assembly of the hoist is attached to the structure, and the fiber strap is attached to the object to be moved. The ratchet assembly has teeth that allow the strap to move in only one direction at a time. The position of the direction selector lever determines whether the ratchet assembly takes up or lets out on the strap. The handle is used as a lever to operate the ratchet assembly. A crewman operates the handle of the hoist to take up or let out on the strap. If the direction lever is set to take up on the strap, each time the handle is operated, the strap is shortened. Changing the direction selector lever to its other position causes the strap to be let out with each operation of the handle. The last rigging tool we'll look at is a gin pole. It's designed to be attached so that a lifting point is provided at the end of the gin pole. This gin pole has a short fiberglass pole that's attached to a base or saddle. The saddle is attached to the utility pole with a chain binder. A gin pole is designed to be used to keep the load away from the pole when necessary. Here, the gin pole is used to hold a block and tackle so that a transformer can be lifted without dragging against the structure. We've just seen some examples of the general safety considerations and tools that apply to planning and rigging a job. Remember that rigging has 2 basic purposes: to control a load and to provide a safe electrical clearance. Regardless of the method you use to accomplish a job, 3 basic guidelines always apply. These rules are planning the job thoroughly, inspecting the equipment carefully, and using the equipment properly. In the next part of the program, we'll look at the stresses in a typical distribution structure, and we'll see how typical rigging jobs can affect the safety of structures.